Greetings. Today we will be showcasing our new benchtop laboratory scale bioreactor system, the EDF-5.5. The system consists of two main components, the bioprocess control unit and the glass vessel. The user has the option to select between two different types of glass vessels, the bottom heated one and the classic jacketed vessel.
In this video, we will be focusing at the standard configuration of the EDF-5.5, but it is important to note that this system can be vastly customized to suit any application needs. For example, you can even switch to larger volume vessels like the 15-liter vessel, or customize the system by adding different types of supporting equipment, for example analog pumps, sensors, and so on.
The bioprocess controller ensures the control of such parameters as temperature, dissolved oxygen, pH, the addition of different titrants, for example for pH control, for controlling the foam level, the medium level inside the vessel, and for feeding.
The Bio5 bioprocess control unit ensures the connectivity of different devices, including for data gathering. It is equipped with 4 peristaltic pumps, which can be controlled from the user interface. Furthermore, the bioprocess control unit is used to control the temperature and connect such sensors as temperature, pH, DO, and so on. Also, it is equipped with 2 gas lines to supply both oxygen and air for DO control.
During this video, I will go through the configuration of the bioprocess controller and the glass vessel separately. And now we will start by looking closely at the design of our glass vessels.
I will start by dismantling the upper lid of the vessel and showing you the elements which come in the package for the standard configuration. In this video I will be mostly focusing on the fully jacketed vessel, as the bottom heated one is very similar. It is important to note that the vessels shown here are mainly used for bacterial or yeast fermentations. For cell cultures, the vessel will slightly differ. For example, other ports will be provided for supplying the gases to the overhead space. Also, the design of the sparger and the agitation system will slightly differ. For example, as you can see in this system, Rushton turbines are used as the agitators, but in the cell culture vessels, the turbines will be exchanged to either propeller or marine type impellers. So now I will fully disassemble the lid and show you the main elements. By default, the vessel is equipped with a bottle holder which supports 3 bottles and the glass body with a jacket. Additionally, multiple ports are provided for either mounting the sensors or for supplying the liquids to the reaction medium. All of our vessels are equipped with a magnetic mixer which provides low friction and high power agitation. Additionally, the vessel can be equipped with different types of spargers, for example ring spargers as seen here, or micro spargers. Now I will show you the procedure of assembling the magnetic mixer. So first of all, you have to put the silicon carbide bushings onto the hermetic housing. These bushings ensure that there will be no friction between the impeller and the hermetic housing itself. Placing the impellers is quite simple, thanks to the fact that the magnetic force pulls them to their correct positions, and the user only has to make slight adjustments to the position of the rotors. 2 bushings are placed from both sides of the rotor. First, you have to position the upper rotor on the hermetic housing. Here it is important to note that the user has the option to select different types of impellers. Here you can see we are working with Rushton type turbines, but the user can exchange them to either pidgeot blade turbines or marine impellers without the need of reconstructing the magnetic mixer itself. So after placing the rotors on the magnetic mixer, you can see by rotating the inner axle, the outer rotors rotate simultaneously. This provides the agitation of the reaction medium. After the rotors are mounted, you can put the sparger in its correct position, and then it is possible to mount the upper lid of the vessel into the bioreactor. After placing the lid on the body of the bioreactor, you have to screw it in place by using the provided screws. First, position the upper lid so that the holes on the lid and on the vessel align, and begin screwing in the lid. Working with the fully jacketed vessel is quite similar to the operations of the bottom heated vessel. Thus, the main principles which I am showing you here are similar. Additionally, on our website we provide a detailed manual of the main procedures and how to perform them for the EDF-5.5 system. After the lid is placed, you can begin assembling the ports which have to be mounted on the upper lid. Additionally, it is important to emphasize that we, for all of our models, provide the possibility of mounting a gas condenser on the vessels, and the position of the gas condenser can be adjusted either for its working position as shown right here, or it can be lowered for autoclaving. And the gas condenser is equipped with a valve which is used for regulating the overpressure, which in most fermentations has to be maintained. Here I am mounting the port which connects to the inlet of the gas condenser by using a silicone tube. Next, we will look at how the level and foam sensors are mounted. So the foam and level sensors ensure the possibility to measure the level of the liquid and the foam, and to provide the relevant control signal to the bioprocess controller, upon registering which either the anti-foam is provided by using different types of needle ports as shown right here. By standard we provide either the one-way needle port or the three-way needle port. Also, in the standard configuration of the EDF 5.5, we provide a chemostat port, which can be used either for harvesting the reaction medium or for supplying different types of titrants, for example feeding. Also, the standard package comes with a set of plugs which can be used for closing up the unused ports of the vessel. And as you can see, the lid of the vessel is equipped with either larger or smaller type holes, so plugs for them are provided. Next, we will look at the temperature sensor. So the standard configuration of the unit includes 3 sensors, and the temperature sensor is also mounted in the same type of port as the chemostat tube. Here are the adapters for the pH and dissolved oxygen sensors, and it is important to note that the ports which are equipped with longer equipment, for example sensors, they go on the outer radius of the lid. When talking about sensors, we closely work with Hamilton sensors, and so for any of our units by standard we equip them with a set of Hamilton pH and dissolved oxygen sensors. And it is important to note that upon user requirements we can provide either the newer line of sensors which work with the ARC system, or the standard polarographic and pH electrodes. So here I am showing you how to mount the pH sensor, so it has to be mounted in the respective port by using an adapter, and as I already said, all of the assembly is performed only by hand, so you don't have to use any sort of tools to do it. Also, considering that the different types of applications require different types of control and for example measuring different types of parameters, our vessels can be equipped with additional sensors. So that includes, for example, sensors for methanol, online measurements for measuring the optical density, the viable cell density. As long as there's enough room on the upper lid of the vessel, we can provide those options for the user. And basically here I'm showing you the fully assembled vessel, which in principle is ready for autoclaving. Also, we provide a motor for the vessel which supports the possibility to provide agitation of the reaction medium. By standard, the range of agitation rates is from 100 to 1000 RPM, which is suitable for most high oxygen requirement applications. And this is the only part of the assembly which requires the use of tools. So by using an Allen wrench you have to slightly tighten the knot of the motor to ensure its position. And here is a vessel which is fully ready to begin operating. The main difference between the jacketed vessel and the bottom heated vessel is the possibility to mount a sapling valve in the bottom part. Next, we will look at the user interface of the Bio-5 bioprocess control unit. To begin working with the system, you first of all have to log in. By default, we provide 3 access levels for the users, which can be used to distinguish between different types of personnel. So the admin, the controller, and the operator provide different access to different functions of the unit. In the authorization window, you can either log in, create new users, delete users, or change passwords. Additionally, in the authorization window, you can observe the logs for alarms and for events. And also you can access the window where you configure the alarms which have to be active or inactive during your operation. In the main window of the Bio5 bioprocess control unit, you can interact with different elements. For example, pumps. You can switch them either to manual or automatic control, enable, disable the elements by hand, operate them at their maximum capacity using the respective buttons. Also, if the pump is calibrated, you can input the required productivity and enable the pump, and the pump will also automatically count the volume which has been transferred to the bioreactor vessel. And also you can refresh the pump to delete the already counted volume. The same principles work with the agitation system. You can switch it to manual mode, input a set point value, and enable the agitator. And the elements switched to manual mode are also highlighted by a small M symbol next to the element. The same principles of working with the elements in manual mode apply also to the gas supply valves and also to the heating elements. So for example, like the circulation pump, the heater, and the cold water valve. Also in the main window you can set up the parameter set points for temperature, dissolved oxygen, pH, and observe the graphical trends of temperature, DO, and pH. From the main window you also can switch to the graph section, and where you can configure the graphical trends of different parameters by adjusting the y-axis minimal and maximal values. And basically in the trend window an option of observing all loggable parameters is provided. Also from the main menu you can access the recipe section, where you can configure the recipes, where you can update them or load them from a USB drive. You can save them to a discrete USB drive and so on. In the settings window you can set up the parameters for your fermentation. That includes the ranges of control, for example like the agitation. You can set up the set points for temperature, pH, DO, and so on. In the second section of the settings window you can perform, for example, pump calibrations. You can specify the amount of calibration points which is required. Up to 10 points is possible. And then you can either adjust the values manually by hand, or you can perform a real calibration during which the pump is enabled, and your basic goal is to measure the amount of volume of liquid which is transferred during the calibration. But also, if for example you already have a set of calibration data, you can just input it by hand and press the Save Changes button. Here I am showing you how the window for the real calibration looks like. So after reaching the end of the calibration, you can input the volume and press save, and then the productivity of the pump will be automatically calibrated. And to save the new calibration data, you have to press the save changes button. In case if the calibration data has some discrepancies, so for example at higher RPMs the productivity is lesser, then the system will automatically register this fact and won't let you to save the changes. And the principle of pump calibration is applicable to all peristaltic pumps used. Next, we will look at the pH calibration window. So as you can see, you have two different options: either correct the pH value with a separate sensor, or to calibrate the sensor by using 2-point calibration. So basic principle is that you place the sensor in two types of buffer solutions and wait for signal stabilization. After stabilization, you save the newer data. For the dissolved oxygen sensor, you also have two options to calibrate it by using either 1-point or 2-point calibration. The principle is very similar. You have to place the sensor either into oxygen depleted or oxygen saturated environments and wait for signal stabilization. Next, you can configure the pumps according to their respective functions. So for example, which pump will supply what type of titrant. The next setting which you can perform is to set up the DO cascade setting. So the DO cascade operates according to the principle of what type of control will be used for maintaining the dissolved oxygen, either the stirrer or the stirrer with oxygen enrichment, or the stirrer with oxygen enrichment and with feeding control. From the main window of the control unit, you can start the fermentation. You can specify the point of inoculation, what time it was performed, and what volume you have introduced into the reaction medium, the amount of sample taken at a particular time point, and the amount of induction agent supplied to the reaction medium. Those parameters are used to log the volume which is currently inside of the vessel. Furthermore, you can access the summary window where all of the essential parameters are presented in a table, which is quite convenient for some of the people working with our systems. This was our short introduction to the new EDF-5.5 bioreactor system, the main design aspects of the bioreactors themselves, and the bioprocess control unit, its functionality and main features. It is quite important to note that also this system can be equipped with a SCADA system, which can be used for remote control of the bioprocess. And also I wanted to mention that if you will have additional questions regarding some of the more in-depth features of the system, you can always access our website, and in the laboratory scale bioreactor system section you can download the user manuals for this system, where all of the main procedures, all of the main algorithms, control algorithms that is, are described in high detail. And regarding the operation of this system, the maintenance is quite simple in terms of standard procedures which have to be carried out annually. Most of them are aimed towards maintaining the sensing equipment, and for those the manufacturer, Hamilton, provides in-depth tutorials and description of procedures. As is for the unit, most of the maintenance procedures are aimed towards the magnetic mixer, so how often you have to dismantle it, how often you have to inspect both the rotors and the hermetic housing. And for all of our systems, at least the laboratory scale bioreactor systems, we provide a warranty for 2 years. And that includes also service. If we don't have a distributor in your country, we perform the service ourselves, either remotely or on site. And if we work with a distributor, then most of the dialogue is performed through him and with his help. And also we provide options for post warranty service. Yes, and if you have additional questions, you can always contact us via email, via sending us a direct message either from our website or reaching out to us on social media platforms such as LinkedIn. So thank you for watching this short video tutorial on our newest bioreactor system.